Okay, hello, welcome back. This is Test 2 review for College Algebra, Math 1530. And I'm just going to go over some problems that are similar to what you're going to see on the test. And I'll note sort of the question pools. So if you go into the book and look at problems 21 to 27 odd, and then 45 to 49 odd, those are the types of problems that I'll be picking from at least 2.1. Of course, the test is on my math lab. You're going to have two possible, you could take it twice, I believe, so that you have two chances in case you do something silly on your first submission. You could go back and hopefully change it. But anyways, from 2.1, if you want to go in and look at the types of problems, you can kind of tell if that's the type of problem by looking at this number right here that says 2.1.19. Okay, that's not in my set of 21 to 27. So I'm going to go ahead 2.1.21. Yeah, so that's the kind of problem that you would see on the test. So let's look at that one. It's a division problem. I expect you to know how to add and multiply complex numbers though, so I may even put one of those on there just to keep you on your toes. But let's take a look at an example. This is 2.1 number 21, and it's division 6 all over 2 minus I. Okay, so to complete division, you just need to multiply top and bottom by the conjugate, right? So let me expand my viewing window here. So we go 2 plus I in the numerator and denominator. And the numerator, you have to distribute the 6. So you'll have 12 plus 6I. And the denominator, you're foiling. So you get 4, the first, the outer, plus 2I, the inner, minus 2I. And then the last be minus I squared. And then we simplify. We need to get it in the form, eventually, A plus BI. Okay, so you may have gotten some questions wrong in my math lab, and it's because you didn't maybe put it in this form. Got to put it in that form. It just makes it easier to read. Okay, so we have 12 plus 6I in the numerator, and downstairs the 2 i's cancel. So I'll have 4 minus, you could replace I squared with negative 1. So I'll have 12 plus 6I all over 4 plus 1, which is 5. And then to get it into our A plus BI form, this form that I wrote to the left, you're just going to butterfly this fraction. Okay? So it's the reverse of finding a common denominator, basically. And A is 12/5, B is 6/5, and then you have your I. Okay? So you would type that in. 12/5 plus 6/5, and then I. And then check your answer, and yay. Okay, let's look at another one. So I also say problems like 45 to 49 odd. So let's sort of fast forward. And, geez. Okay, so it's probably one like the end guys here. No. So it should be like a quadratic type where you're solving a quadratic equation. It's this one. It's around there, so it's after that one. That was 19. Okay, so let's try 21. Great. Sorry. I have to literally go one by one until I find. Oh, here we go. Okay, so solve. This is 2.1.45. So that's like the easiest version of a problem I could give you. We need to solve it using the quadratic. So x squared minus 8x plus 41. Okay. Okay, so you need to use a quadratic formula, so you have to have that formula embedded in your brain somewhere. The A value is 1, the B value is -8, the C value is 41. So I'm going -8 is 8, plus or minus the square root of B squared, 64, minus 4 times A times C, which is 41. Okay, so 41 times 4, 164, and then I have to subtract away 64. It's going to give me 100, but negative. And then that's all over 2 times a. So that'll be 8 plus or minus square root of negative 100 all over 2. I always want to march out the imaginary part. So I'll have square root of 100i over 2. And then simplify the square root. So that's just 10. The square root of 100 is 10 over 2. And then you can butterfly that thing. You get 8 over 2 plus or minus 10 all over 2i. So see, it's in my a plus bi form. And then that's just 4 plus or minus 5i. So you either have 4 plus 5i or 4 minus 5i. Okay? 4 plus 5i, comma, 4 minus 5i. Okay. Okay, so that's 2.1 stuff. Just, either do the problems that are similar in my math lab, or literally you can just go to the book and there'll be similar problems there. Okay, let's go on then to 2.2. Okay, so in 2.2, I'm looking at problems like 17 to 37, and this was about graphing parabolas. And so we had basically 2 forms. There was like the vertex, this form where you could read the vertex off of it, and this other form where you had to have the equation for the vertex memorized. So if you have f of x equals ax squared plus bx plus c, you need to know the vertex h comma k will be h equals negative b over 2a. And then k will be f of that. So you just plug negative b over 2a back into the function, and that gives you the y coordinate of the vertex. Okay, the other form was a times x minus h plus k. And in that case, you could just literally read the vertex off of that formula. There were some other issues such as domain and range, and it came down to basically the picture. Okay. So we had these 2 kinds of pictures. For the first type, that's when a, the leading coefficient, is greater than 0. And in that case, the domain is always the same. The domain is always negative infinity to infinity. Okay, so for both cases, infinity to infinity. It's the range that is different for these 2 cases. So in the first case, it's going to go from the y coordinate of the vertex to infinity. So you could say, I guess our y coordinate is k, right? So let's put k to infinity there. Yeah. And in the other case, it's negative infinity to k. So negative infinity to k on top. The axis of symmetry then is going to be the x coordinate of the vertex, and that's true in both cases. Okay, so that stuff you kind of have to have embedded in your brain, in other words, memorized. You could tell though the domain and range by looking at the graphs. But anyways, let's take a look at maybe 1 or 2 from the Webassign problems. Okay, so homework, and we're looking at 2.2, and I don't know, let's look at 13. Is that in our range? Yeah, it is. Okay, so use the vertex and intercepts to sketch a graph, the quadratic, give the equation for the parabola's axis of symmetry. Make sure you're reading the directions, okay? That'll help you avoid any mistakes. Use the parabola to identify the function's domain and range. Okay, so basically just everything that we kind of already have been doing. Let me copy that. X squared plus x minus 2 is our example. That's our f of x. I should put the f of x on the other side, but there it is. Okay, so you can kind of identify the form just by looking at the leading coefficient is 1. That tells me it's going to be this U-shaped, and that automatically gives me the domain and range if I had the vertex. Okay, so the vertex is definitely something that you want to get out of the way next. So I kind of have a method. I always get this information first. Then secondly, I get the vertex. So the vertex in this case, A is equal to 1, B is equal to 1, and then C is -2. We don't need C, but so the x-coordinate will be negative B all over 2 times A, which is A is 1. So this will be -1/2. And then for K, you're just going to plug that back into the original function up here. Okay, so you're going to go -1/2 squared is 1/4. Plus 1/2 minus 2. Find a common denominator there. 1/4 plus 2/4 minus 8/4. And then that's going to be 3 minus 5/4. Okay. And for graphing purposes, you may want to get decimal 1.25. Okay, but ultimately our vertex then is -1/2 comma -5/4. Okay. Okay, from that point we can get, of course, our domain is easy. It's just -infinity to infinity. The range then, because of the shape, over here to the left, it's upward shape. It's going to start at the y-coordinate of the vertex, so -5/4, and then just go to infinity. We also need our axis of symmetry. Okay, so AOS, that's just the x-coordinate of the vertex. So in this case, the equation x equals -1/2. And then finally, you need the x and y-intercepts. For the x-intercept, you let y equal 0. So I'll have 0 equals x squared plus x minus 2. In other words, let's see if we can actually factor it. Sometimes you have to use a quadratic. That's a very sad day in math land. But here, let's see what we get. Okay, so I think I'll have to go plus 2 minus 1, and that will give it to us. Okay. So at the end, then x is -2, and then x is 1. And then finally, the y-intercept, that's easier. You just can literally read off the last entry on the quadratic. The y-intercept is -2. Or you just let x equal 0, and you get y is -2. Okay. Okay, and then we have to graph the thing. So let's just see what we have to do in Webassign here. Okay, so I'll kind of move this over here and move this guy over here and go ahead and get to work. Okay, so use the vertex and intercepts to sketch. Okay, so I need a parabola thing. And the vertex -1/2, so -1/2, and then down, oh gee whiz. Yeah, oh, they're giving me 0.25, it's good. So down 1.25, -1.25. Okay, and then I need an x-intercept, okay. So I'll go over to my x-intercepts. The one to the right is at 1. Okay, so I'm going to put that at 1. And then save and see what happens. Make sure I got it right. What is this point? -0.5. -1.25. That's good. Let's see what I did wrong. I apologize. -0.5. That's -1.25. All right. And then my x-intercept is at 1 and -2. Oh, I see it. It's right here. Hold on. Sorry. It's not letting me erase for some weird reason. Oh, okay, sorry. Let's see. It's right here. Yeah, silly mistakes. So this is minus. This would be minus 8, it should be 9 fourths. 8, 9, 10, so 9 fourths. So this is 9 fourths. And so this guy should be negative 2.25. Okay, let's see if that works. Okay. All right, the axis of symmetry. So here it says in parentheses type in equations. So you got to be careful. You can't just write in, x is negative 1/2. I mean, you can't just write in negative 1/2, right? You have to write x is negative 1/2, and then that'll do it. The domain is always the same, so it's always negative infinity to infinity. And then the range is based off the intercept, so just be careful. We got negative 9 fourths to infinity. Oops, I need a bracket there. 9 fourths to infinity. And what else? Oh, that's it. Okay, so yeah, okay. Let's try one more of those. Let's do a vertex form, if there are any. Maybe they were before this one. All right, so let me go back. I don't know where I was. Maybe back here. Sure. Okay, so again, it's the same spiel, but it's a different form. So the example they're giving us, f of x equals 9 minus x minus 4 squared. So this time it's in the vertex form. And we can kind of zip through and do this one. You probably want to rewrite it so it's more identifiable. So the a value is negative 1. And that tells me it's a sad face parabola. The vertex, you can read directly off of it. You just take the opposite sign of the negative 4, so that would be 4. And then the same sign as the next guy, so that would just be 4, 9. Thirdly, then, what do we need? The domain and range. So the domain, of course, negative infinity to infinity. The range, because it's a sad face, it's going from negative infinity to the y-coordinate of the vertex, 9. The axis of symmetry is the x equals the x-coordinate of the vertex, 4. The x and y-intercepts. So for the x-intercept, you let y equal 0. And this should be squared. Negative x minus 4 squared plus 9. We can add the x minus 4 squared to the other side, and then use the square root property. So x minus 4 is plus or minus root 9, which is 3. And then x equals 4 plus 3, which is 7, or x equals 4 minus 3, which is 1. And you can get the y-intercept. I don't think we need it here, though. Let's see what we actually do need. So I'll go ahead and graph on here. I need this thing. So 4, 9. 1, 2, 3, 4. 1, 2, 3, 4, 7, 8, 9. And then 7 or 9. Let's go with 7 and see if that's good. Then the axis of symmetry, type in an equation, please. X equals 4. Okay. And then the domain, always negative infinity. Maybe it'll allow me to do backslash infinity. Yeah, it does. Comma backslash infinity. Answer. Okay. The range, of course, sad face, so negative infinity to 9. It should be a closed bracket on 9 in my notes over here. Okay. So open parentheses, negative backslash inft to 9 bracket. Whoops, wrong kind of bracket. There we go. Anything else? Nope. Okay, that's all we need for that. So we'll move on. Okay. All right, so the next type in 2.3 are polynomial types. So let's get in there and see what we got. Okay, so 2.3 now. I'm looking at questions like 41 to 63 in the book. Let's see what they look like in my math lab. Okay. And I need to do homework. And we're in 2.3 now. And let's go take a look. So this is problem 27. If you look at the green check mark, we don't want that. We want 41 to 63. Okay, so let's fast forward a little bit. Okay, so here's one. All right, so let's kind of try to go through the. I mean, in my head, I have a sort of process for doing these. So I'll go through my process and then I'll answer the questions in my math lab. We have f of x equals x to the 4th minus 16x squared. Okay, so first I identify the shape in the end behavior, and this is even degree. So even degree. And the leading coefficient A is 1, which is greater than 0, so it's going to have this kind of crazy behavior. Okay, and of course that's the first question they're asking anyway. So it's rises left and rises right. So let's see. Let's see what else I need to find. Yeah, so I would get the x and y-intercepts next. So x and y-intercepts, and you just set the thing equal to 0 and solve for all the intercepts. So I can factor out an x squared, and I get x squared minus 16 is 0. And then I have x squared times x minus 4 times x plus 4 equals 0. And so I'll have x squared equals 0. And so x equals 0, but that x squared tells me its multiplicity is 2. Okay, so it has a k value of 2. In other words, it's going to bounce off the x-axis at that point. And then x is 4 from the second factor. And of course, that multiplicity is 1. And then x equals negative 4, and its multiplicity is also 1. So it'll go through the graphs, the x-axis on both of those points. The y-intercept, you let x equal 0, so y will just be 0 to the 4th minus 16 times 0 squared, which is just going to be 0, okay, for the y-intercept. And that's usually pretty much all they want. Let's see what they want. They might want turning points as well. So the max number of turning points, max TP, is always going to be 1 less than the degree of the polynomial. Okay, so our degree was 4, so the max number of turning points is 3. Okay, and hopefully that'll get the job done. We'll be able to answer all the questions. Okay, so the x-intercepts again, 0, 4, and negative 4. Okay. At which zeros, so this is the multiplicity question. At which zeros does the graph cross the x-axis? So that's going to be at 4 and negative 4, because their multiplicity is odd. Where does it bounce off? So that's at 0, because the multiplicity was even. Find the y-intercept. We did that already. That's just 0. And, determine the symmetry. Right, so if a polynomial has all of the same powers that are even, then it's even symmetry automatically. Okay, you don't even have to mess around with it. Okay, so if it's all even powers, it's an even function. If it's all odd, it's an odd function. Okay. Then they want an idea of the graph, and know that it's bouncing off, and then it goes through it twice. And there's only one graph that seems to be doing that, and that's D. Okay. So there is the symmetry issue then that we always have to worry about. So let's look at this next one. This one has mixed powers, and when that happens, it's not going to be either or even or odd. It'll be neither. Okay, so just get that out of the way right here in the beginning. If you want to, you can always do that substitution of negative x. So, okay, let's look at this example. F of x is x to the 4th plus 6x cubed plus 9x squared. Thinking about even and oddness, then you're plugging in negative x. Okay, so I got negative x to the 4th plus 6 times negative x cubed plus 9 times negative x squared. The first guy is going to end up being positive because it has an even exponent. The second guy is going to be negative because of an odd exponent, negative 6x cubed, and then plus 9x cubed. So when you have you need either all the signs to change or all the signs to stay the same for this to be even or odd. If all the signs stay the same, it's even. If all the signs change, it's odd. So if neither is the case, then you have neither, basically. And that's this case. So you can see that like 2 of the terms changed sign, but then this middle one didn't. So that's neither. Okay. Even nor odd. Okay, let's get the other questions now. So again, I usually start with just figuring out the behavior. The degree, again, is even, it's 4. The a value, again, is 1. That's greater than 0. So that's going to mean it's this kind of happy face type deal. And so it's rising on the left and the right. So rises, let's see, rises to the left, rises to the right. Okay. Find the x-intercepts. So the x, and you let y equal 0. So you have 0 is x to the 4th plus 6x cubed plus 9x squared. You can factor out an x squared. So I get x squared plus 6x plus 9. Then hopefully factor. And I think we can. So I have x squared times x plus 3 times x plus 3 again. So that's just that's going to give us a multiplicity 2 on that 0. So if you take up the pieces, here we have one root is 0 and it has a multiplicity 2. And then because of the exponent on that guy, x plus 3 is 0, x is negative 3, with again another multiplicity 2. So those are both jumping off. The y-intercept, then you let x equal 0, and of course that's just going to give you 0 for the y-intercept. Okay, so x-intercepts 0 and negative 3. And then there are no x-intercepts that cross the x-axis because the multiplicity is even in both cases. X-intercepts where it goes through, or sorry, it bounces off. That will be both of them. So 0 and negative 3. Okay. Find the y-intercept. That's just 0. That's when you let x equal 0 and solve. And then it's neither symmetric about the y-axis. Y-axis symmetry means even symmetry. Origin symmetry means odd symmetry. Okay, so this is neither. And then the graph, so it has a happy face on the ends. So it's either A or B, and then you can tell which one it is by looking at the x-intercepts. So clearly it's A. Okay, so a couple of those. Then we move on to long division in section 2.4, I believe. Okay. So let's look at like I chose problems 1 to 31, so this is fair game right here. So let's try this guy. Okay. And clearly, if you can do synthetic division instead of long division, you might want to do that. Sometimes it's not allowed, right? So let's see. Like here, you wouldn't be able to do long division at all. So, I mean, you wouldn't be able to do synthetic division. So let's try this guy. And this is now 2.4 problems. And I'm picking problems like 1 to 31 from the book. Odd. Okay, guess I didn't mention that. Did I mention that for 2.3? No, I didn't. So this was, yeah, I did. 41 to 63 odd. 2.2, 17. Okay, I'm doing my job. Okay. Yeah, so 2.4, long division, problems like 1 to 31 odd. And here we go. So I got 10x squared. I'm just going to go ahead and write it in the long division form. Minus 2x divided by 2x minus 1. Okay. So what times 2x is 10x squared? So I say, okay, 5x. So that's 10x squared. Distribute the 5x, so minus 5x. And then I'm subtracting all that. Okay, so that's going to be 8x, bring down minus 2. So make sure you're distributing that negative to both terms. So 3x plus 5x is 8x, bring down the negative 2. So what times 2x is 8x? Well, that will be 4. So you'll have 8x minus 4. Then you got to subtract. So I'll have 8x minus 8x, 0. Negative 2 plus 4 is 2. And so my answer should be 5x plus 4. And you're doing this kind of clockwise rotation plus the fraction 2 all over 2x minus 1. Okay? And you just go over here and type it in. X plus 4. You just put a 2 up there and make sure. Let's make sure. I'm going to make sure it's right. Okay, so next, you can do synthetic division if that comes up. Let's find one maybe that's a little more harder with some placeholders or something. Okay, so this one, let's try synthetic division on it. So you put the opposite, so if it's 3x squared plus 4x minus 7 divided by x plus 3, you're putting the opposite of plus 3 into this little, so you're dividing by negative 3 basically. And then you have 3, oh, I didn't use a placeholder. There's no placeholder on this one. Let's try a different one. Well, no, let's go ahead and clear that one out. Maybe we'll have time for another. So, okay, so it would be 3, 4, negative 7. Okay, so you drop the 3 down, and then it's negative 3 times 3 is negative 9. 4 minus 9 is negative 5, and then 3 times negative 5 is 15. And then 15 minus 7 is going to give you 8. So our answer will be 3x minus 5 plus 8 all over x plus 3. Okay. So x minus 5 plus 8. So I removed a bunch. I felt sorry for you guys. You have to do so much homework. This one's kind of weird. Sure, let's try this one just because of its weirdness. So if one of the, no, I want to do, so for this one you got to rearrange the terms, right, to make them in order before you can do the synthetic division. So you'd have to go for your row 1, negative 7, 2, negative 14, and then 0. Okay, so there is kind of a placeholder. Let's go ahead and try this one. Okay, so it's going to be negative 7 in the box, because it's really, if you rewrote it, maybe we should rewrite it first, right? So if you rewrote it, it's x to the 4th minus 7x cubed plus 2x squared minus 14x, and then technically plus 0, and then we're dividing it by x plus 7. Okay. So in the box, we're going to put a negative 7, and then in our row, we got 1, negative 7, 2, negative 14, and then 0. So you still need a placeholder at that end place. Okay, so bring down your 1, and then negative 7 times 1 is negative 7, so that would be negative 14. and then 14 times 7, 279, positive 98, and then this will be 100, and this will be negative 700, and then this will be negative 714. Ugh, numbers are starting to snowball on me. Let's get a calculator so I don't screw it up. Calculator. 7 times 714 is 4998. Positive 4998. And I don't know how that happened. 998. Okay, so our answer, 1 degree less than the original polynomial, will be x cubed minus 14x squared plus 100x minus 714 plus 4998 all over x plus 7. Okay, so let's see, that seems crazy to me, but let's go ahead and see. So we got x cubed minus 14x plus 100x minus 714, and then 4998. Yeah, I was afraid that might not be right. Well, let's see what we got. Did I copy it right? X to the 4th minus 7x cubed plus 2x squared minus 14x plus 0. That's good. 1, negative 7, 2, negative 14, 0. And there's negative 7, negative 7, negative 7, negative 14. 7 times 98. Oh, I typed it in wrong. I forgot to put the square in there. Okay. Right, so let's see what else we got. There's then I'm not going to put in 2.5. We're just going to skip to 2.6, and that's all about graphing rational functions. Okay, so 2.6. I'm thinking of questions similar to 57 to 79 odd. Okay, and let's take a look. So homework. Yeah, homework. I'm going to go homework. So 2.6, and I don't know, we'll try 13, see where that leads us. It's been removed. No. Okay, 7-step strategy. That's number 57 right there. Let's try a different one. Let's try, yeah, sure, this one. Okay. So, example here. F of x equals negative 1 all over x squared minus 4. Okay. Okay. So the first thing they're going to want is a symmetry. And what I suggest doing is kind of split it into a numerator. So the numerator we could say is negative 1 if you just rewrite it with the negative up top. And the denominator q of x is x squared minus 4. So p of negative x is still negative 1. Okay, so that's good. If nothing changes, then you still have a chance. If nothing changes or everything changes sign, then you still have a chance for it to be even or odd. So that q of negative x, if you put in negative x for x squared, you get out q of x again. So x squared minus 4, which is q of x. So the numerator does not change, the denominator does not change, so the entire thing does not change, basically. So this one has to be even symmetry, which they are in my math lab are calling y-axis symmetry. Okay. Okay. So oops, I didn't want to do that. Okay, so apparently I already answered that. Y-axis symmetry. Okay, and then I basically just have steps to doing this. I get the x and y intercepts. For the x-intercept, you let y equal 0, so 0 is negative 1 over x squared minus 4. For the x-intercept, it's always just about letting the numerator equal 0, right? So if you multiply both sides by x squared minus 4, you'll get that, the numerator equaling 0. 0 is when you have a false statement resulting, that just means there's no solutions, and in this case, then there's no x-intercept. Okay? For the y-intercept, you're letting then x equals 0. So you'll have y equals, so I'm putting in 0 wherever I see x, so negative 1 all over 0 squared minus 4, which is negative 1 over negative 4, which is 1/4. Okay, so our y-intercept, at least we have one of those. And the y-intercept is what they want right here. The x-intercept, there is no x-intercept, we just figured that out. Okay. And then I think we want vertical and horizontal asymptotes. Okay, so it looks like they want the vertical asymptotes next. So for the vertical asymptotes, that's where the denominator is going to equal 0. So you just take the denominator of the expression, set it equal to 0. Here we can use the square root property. So x is plus or minus 2. So x is 2 or x is negative 2. So for the vertical asymptotes, they're going to want the equations, not just 2 and negative 2, all right? So note, it says type an equation. Use a comma to separate your answers. Okay, so we have x is 2, comma, x is negative 2. So make sure you're reading those directions. Horizontal asymptotes. Okay, so for the HA. In this case, the degree of the denominator is greater than the degree of the numerator, so the horizontal asymptote is just y equals 0. And again, you're going to have to put in an equation. Okay, so this will be y is 0. Okay. Then they're going to want you to do a bit of a table of values. I'm going to need my calculator to pull this off. So 64 minus 4 is 60, so maybe I don't need my calculator. Okay, so negative 1 over 60. Okay. This will be negative 1 over 25 minus 4 is 21. This will be just 1 over 4. This should be the same as negative 5 because it's even. 1 over 21. Same for this guy. Negative 1 over 60. And then they probably want a graph. Okay, there's two vertical asymptotes, right? At 2 and negative 2. So if your graph does not have that, okay, so they all have 2 and negative 2. Okay, whatever. Horizontal at 0, so we could throw out B and D. Neither of those will work because of the horizontal asymptote. So it's either A or C. I'm going to need to zoom in on you. Okay, so the difference between A and C is that the middle part on C is positive. Okay, so in between negative 2 and 2, you should have positive values because of our chart here, where you have 0, 1/4. That means it's above the x-axis, and that if you plotted that point, it would be on C, not on A. I believe A is negative in that interval. Okay, so C, and then that's kind of the whole spiel. Okay. Okay. Should we look at one more? Ooh, look at this guy. Sure, let's look at one more. So this guy, the example f of x equals x squared plus x minus 12 all over x squared minus 4. And so first, what do we do? The symmetry. Okay, so the numerator p negative x. If I put negative x in, I get negative x squared plus negative x minus 12. equals x squared minus x minus 12. So the problem here is one sign changed, but the other two didn't. All of them have to stay the same, or all of them have to change for you even to have a chance of even or odd symmetry. So this is a neither right off the bat. Okay, and I already went through and did them all in my video, so I already have that one checked off. Okay. Okay. Secondly, then you're probably after the x and y-intercepts. Okay, so for the x-intercept, you're letting y equal 0, but that always just comes down to setting the numerator equal to 0. Okay. And if we solve this, hopefully we don't have to use a quadratic formula. This is x plus 4, x minus 3 is 0. So x is negative 4 and 3. The y-intercept, you're letting x equal 0. So y will be 0 plus 0 minus 12 is minus 12. All over 0 squared minus 4 is minus 4. So it'll be 3. Then we need, so let's go ahead and put those in. Okay. So the y-intercept is 3. Yay. The x-intercept, 3, and then negative 4. Yay. Okay, so vertical and horizontal asymptotes. So for the vertical asymptotes, taking the denominator and setting it equal to 0. Okay, so here we get x minus 2, x plus 2, or if you want the square root property, you can do that. So I'm going to get x is 2, x is negative 2. You need the equations in the answer box. X is negative 2, x is positive 2. Horizontal asymptotes. So in this case, the degree of the numerator and denominator are the same, so you take the ratio of the leading coefficients of the terms. So it's just 1 over 1 for our horizontal asymptote. So y equals 1. Okay. So the horizontal asymptote, y equals 1. You need an equation. Okay. What else? We need a table of that. Oh my gosh, it's going to be a nightmare. Okay, so so here we go. Negative 11 squared is 121. Minus 11 minus 12 is 98. All over 121 minus 4 is 117. So 117, 100 minus 10 is 12, 78. All over 100 minus 4 is 96. (13/16). Negative 1. Okay, so I have 1. Minus 1 is 0, minus 12. So it'll be minus 12 all over 1 minus 4 is negative 3, so it's just going to be 4. On the top, 1 plus 1 is 2, minus 12 is minus 10. Down below, again, we got a negative 3. So this will be 10/3. What we got here, this will be 36 plus 6 is 42, minus 12, 0, 3. So that would be 30 all over 36 minus 4 is 32, which would be 15/16. 15/16, and then 11. There's no way I got these right? 121 plus 11 minus 12. And the top is 120. And then down below, 121 minus 4, 117. There's no way I could simplify that. 120, 117. Yeah. Oh, gosh. So which one is wrong? I think maybe this last guy can be reduced. Okay, so apparently they want this chunk reduced. What is that? I think it's 40 over 39. Can't imagine that's what it is, but okay. You got to reduce your fractions. Okay. What else? So, you know, the vertical asymptotes are at 2 and -2. So if that's not the case, you throw that out. Horizontal at 1. Okay, so, C and D don't have anything on the outside parts, so those are in the trash. So it's either A or B, then you just kind of zoom in on them. So again, the middle interval kind of determines it in this case. So if you look at something in between the two vertical asymptotes, so like 1 and -1, they're both positive. So it shouldn't be B, it should be A, because everything in between the two vertical asymptotes are positive, so it's above the x-axis there. Okay, so those will be challenging for you. Let's go on to the last section. What is this, 2.7 then? Okay. So 2.7 are polynomial and then rational inequalities. Whoops, 2.7. So we have 1 to 31 odd, and then problems like 43 to 59 odd. Okay. Okay, so let's get out of this and go on over to the next section. 2.7. And dive right in. So here we have a polynomial inequality. Let's just try to rip through that. So basically you want to get it equal to 0 to find kind of the frontier points. So let's see what we got. X is less than or equal to 6 minus 2x squared. So I'm going to move everything to one side. I have 2x squared plus x minus 6 less than or equal to 0. And then I need the intercepts. So I'm going to set it equal to 0 and solve. So it looks like I got 2x and x, and then we can go 2 and 3. Yeah. 2 and 3. We need the positive. We need this to be positive, so the plus with minus here. Set each part equal to 0. 2x minus 3 is 0. X plus 2 is 0. So x is 3/2, and then x is -2. The inequality that we're dealing with above has the line underneath, so we're going to be using brackets in our solution interval. Anyways, in the meantime, we have to draw our number line and plot -2 and 3/2, and then we need to do our test value, our sign, and our conclusion. Okay, so I'll pick x is -5, and I'm plugging that number back into this factored form, and all I care about is the sign. Okay, so -5 times 2 is -10, minus 3 is negative. -5 plus 2 is negative. Negative times negative is positive, so it must be above. Okay, try x is 0. If you plug in 0, you'll have -3 times 2, that's a negative. That'll be below. That'll be in our solution interval. Try x is 5. So if you plug 5 in there, you'll have a positive times a positive, which is positive, and that'll be above. Okay, and we're going to be using brackets. Our solution then matches with the inequality from the original there. So we want this interval, and we're using the line underneath means these are kind of included. So you know, closed dots or brackets, whichever you prefer. And so our solution interval will be from -2 to 3/2. Okay. So let's try it. bracket -2, comma 3/2, and bracket, oops, and bracket. Okay. All right, and then there'll probably be, oh, so then we need the graph of it. We already have the graph. So -2 to 3/2 with them included. Is that it? Yeah, okay. The other types are the rational inequalities. Okay, so let's zoom on over to those. Okay, so these are kind of the generic ones. Let's look at one of the harder ones, like this guy. Okay, so x, let me get back to white pen. I have x plus 2 all over x plus 9 less than 2. Okay, so first thing I want to do is get everything on one side, right? You got to set it equal to 0. Okay, and then I need the I need the common denominator. So 2 is the same as 2 over 1. And then I need to multiply top and bottom by x plus 9. Okay, okay, so I'm going to end up with x plus 2 all over x plus 9 minus 2 times x plus 9 over x plus 9. It's less than 0. That'll be x plus 2 minus 2 times x plus 9 all over x plus 9. Distribute x plus 2 minus 2x minus 18. Make sure you distribute the negative to both terms over x plus 9. Then we have negative x minus 16 all over x plus 9. Okay. Then we set the numerator equal to 0 for one point. So x will equal negative 16. And then we set the denominator equal to 0 for another point. For the denominator, you're always going to use an open dot. For the numerator, whether you use an open dot or a closed dot is dependent on the inequality type. Okay? If there's no line underneath, you're automatically going to the open dot. Okay, so let's go to our number line, and then we want to plot these guys, negative 16, negative 9, and then we need our test values, our signs, and our conclusions. So we'll try x is negative 20, okay, and I'm plugging it back into this expression right here. Negative 20 is positive 20, minus 16 is a positive. All over negative 20 plus 9, which is a negative. Positive divided by negative is negative, so that's a less than. Okay, and then we have open dots, or if you'd rather, parentheses. The next interval I'll try negative 10. So negative 10 is positive 10, minus 16 is negative. All over negative 10 plus 9 is negative. Negative divided by negative is positive. So that's greater than. And then we could try 0. That'll give us a negative over a positive, which is negative. That'll be less than. And of course, the interval we want then are the less than intervals. And we are using parentheses, okay, because they're both open dots. Okay, so for our solution then, it's going to be negative infinity to negative 16, parentheses unioned, with negative 9 to infinity. Okay, hopefully that'll do it. Negative backslash inf to negative 16 unioned. I don't know how to type that in. Parentheses negative 9 comma backslash inf and parentheses. And then we need to plot it. We already plotted it, so it's negative 16 and then negative 9 on. So it looks like it's this guy. Yay. Okay, so you're going to have 2 submissions on the test. Hopefully the little mistakes won't add up on you. I know it's easy to make little mistakes, especially when you're inputting answers, and it's not fair to lose credit because this is not a data entry class. This is a class on how to do math. So I'm giving you 2 submissions, and and hopefully that'll be good enough. And the other software system I use, I can actually go in and look at your answers. So if you think that, okay, I put in x equal, or I just put in -2 instead of x equals -2 for like on the asymptote problems, hopefully there will be some way I can go in and check that. Okay, I'm hoping. That's what I could do with the other math software systems. Honestly, I've never given a test in my math lab, so I don't know how this is going to work, but hopefully I'll be able to go in and check to see if that's the case. So if you feel like, you know, you just did a silly mistake, kind of keep it in the back of your mind in case it's possible for me to go in there and check. Okay. So anyways, you could take the test anytime next week. Actually, you could probably take the test today if you want to. Today, for me, being Friday. And you need to have that ProctorU thingamajig, the extension, and then hopefully you just go in there and click on it and go through the prompts, and it'll allow you to take the test. If not, send me an email. Let me know what's going on, okay? Okay, so again, thanks for watching, and we'll see you next time.